Hey, welcome everybody. Hey, this is the first new concept guide we've had in some time. This is 2018 right now. Um, Real exciting. And you know how cold it is outside? I gotta say this before we get going. It's really cold outside, but they got the heat turned way up in here, and it's just really uncomfortably hot. And so I apologize for that. We're working on fixing it. But yeah, this is section 5.4. Our textbook calls this special quadrilaterals. That's a silly name. These are special parallelograms is what this is. This is a pretty lengthy concept guide. It's got a lot of stuff in it, pretty important section. So we're splitting it up into two parts. Yeah, we'll take this through rhombuses. So here we go. Rectangles, rhombuses, and squares are special types of parallelograms. So we've learned the 5 properties of parallelograms. So a rectangle, a rhombus, and a square will have all of these properties. The opposite sides of rectangles are parallel. The opposite sides of squares are congruent. The opposite angles of rhombuses are congruent, etc., etc. The things that we know about parallelograms are also true for rectangles, rhombuses, and squares because they are parallelograms. Okay. Then rectangles, rhombuses, and squares have their own special qualities as well, and that's what we need to learn through this lesson. Rectangles, we add 2 properties to these 5 properties. So rectangles absorb these 5, and then we add 2 to it. First one is one that I expect that you know, because you went to elementary school. A rectangle has 4 right or 90-degree angles. In other words, it is an equiangular quadrilateral. So when you hear that term, an equiangular quadrilateral, that's a fancy way of describing a rectangle. All the angles are the same. Okay, so what happens then if you draw one diagonal? Well, what does that do? That makes 2 triangles that are both right triangles. The opposite sides are congruent. For several reasons, we can conclude that those triangles are congruent. So what does it do? It makes 2 congruent right triangles. That's handy. Okay, and not too crazy. Let's keep going. Yeah, so that's property number 1. That wasn't hard. Property number 2 is going to come from looking at what happens when there's 2 diagonals. So what I've done here is here's triangle ADC over here, and I'm redrawing it over here. And here's triangle BDC over here, and I'm redrawing it over there so we can take a look at this. Now let's apply what we know about it. We know that there's right angles because it's a rectangle. We know that AD is congruent to BC because it's a parallelogram. The opposite sides of parallelograms are congruent. And then this DC is equal to DC because of the reflexive property. It's equal to itself. So what conclusion do we get to make here? We get to say that those 2 triangles are congruent. For what reason? Because of side, angle, side. All our first semester stuff is so good. Then we can conclude then that what's true about AC and BD, the 2 diagonals? Well, because of CP/CTC, AC is equal to BD. There's the corresponding parts of congruent triangles. So what did we just, show or kind of prove? We proved that the diagonals of rectangles are congruent. So your 2 properties of rectangles are, 1, all right angles. 2, the diagonals are congruent. Now that does something else, kind of like a corollary. If all of these sides are congruent and the diagonals bisect each other and they're congruent, look at this. If the diagonals are congruent and they bisect each other, then what types of triangles are all 4 of these little guys? That's right, they are all isosceles triangles. So when you have one diagonal, it makes 2 right triangles. But when you make 2 diagonals, it makes isosceles triangles. Not all 4 of these are congruent. The opposite ones are congruent, if you will. The ones that share the vertical angles are congruent with each other, but like these 2 angles are not congruent with each other. But there are 4 isosceles triangles, and that's going to be really helpful here in a second. All right, so these are some type of questions we'll be seeing. We'll be talking about the lengths of some segments. We'll be talking about angles. So when a question like this just jumps in and says, HIJK is a rectangle, and then find the value of x. And there's no diagram. That confuses a lot of people at first until you draw it. There's rectangle HIJK. What do we know about it? Well, there's 2 diagonals. And what did we just say is true about those 2 diagonals? Because this says, what is HJ and IK? HJ equals something, IK equals something. What are those things? Those are diagonals. It's a rectangle, so therefore they're congruent. So we get to make a pretty simple equation here on number 10. Hj is equal to Ik, so therefore x equals 2x minus 8. Then we can solve that equation. The instructions say don't not only to solve for x, but to find the length of the diagonal. So we got to plug it in. X is 7, sorry. 14 minus 7 is also 7. So what are the lengths of the diagonals? They're both 7. Go ahead. I bet you can do 11, 12, and 13. Pause the video for a moment. Answers will show up momentarily. Okay, how did you do? Did you get these answers? If not, we can certainly talk about it in class. All right, or come see me. And then what happens if we're talking about the angles down here of these rectangles? All right, it gives us this angle up here is 18. How does that help us find any of these other angles? Well, what you're going to learn is that if you know any one of these angles of the rectangle, we're going to be able to find all of the other ones. And it'll become pretty easy, I hope. But the one thing we know for sure, we got alternate interior angles here, right? So we know right off the bat that this angle here, angle 3, is 13. This is a right angle because it's a rectangle, correct? So then angle 18 and this guy over here are complements, so that's got to be 72. So we're filling in some puzzle pieces, and what I encourage you to write in everything that you know. But how do we get to 3 and 4, or even angle 1? This is the key, just like we did on the previous page a second ago. What type of triangles are all of these? They're isosceles. So the rest of this becomes kind of an isosceles triangle question. There's also exterior angles and complements and all of those types of things. But what we got going on here is the isosceles triangles, how we know that angle 1 is also 72, opposite the congruent sides. Angle 2 is the vertex angle, so you just got to do 180 minus 72 and 72, et cetera, et cetera, et cetera. All right, pause it again. See what you can do on numbers 3 and 5. Did you get these angle measures and these angle measures? If not, be ready to talk about it. All right, that's rectangles. Hopefully that wasn't too bad. Let's talk about rhombuses or rhombi. Rhombuses have 3 additional properties, plus 2 other helpful facts. What is property number 1? Well, this is really the definition of a rhombus. A rhombus is a equilateral quadrilateral. In other words, all of the sides are congruent. That's a fact that you really should know before now, but, well, you may have forgotten. So, yes, that is thing number 1. Another helpful thing, though, what happens, therefore, if you just make one diagonal? Well, that makes 2 isosceles triangles, so that's going to help us with some angle measures for sure. Main thing you need to know, all the sides are congruent. Rhombus property number 2, the 2 diagonals of a rhombus are perpendicular. They're perpendicular, so we get right angles in there. As a result, what's created? 4 congruent right triangles. Keep in mind that the diagonals are bisecting each other because it's a parallelogram. So we got this is congruent to that, that's congruent to that, opposite sides congruent, et cetera, et cetera. We get 4 congruent right triangles. All 4 of those triangles are congruent. Property number 3, the diagonals of a rhombus bisect the angles of the rhombus. What do I mean by the angles of the rhombus? Well, I mean this, like angles ACY and ADY and CYD and DAC. So if what is angle ADY equal to? Well, if here start off ACY is equal to 40. Well, ADY is also equal to 40. Why? Because they're opposite angles of a parallelogram. What about CAD and DYC? Well, consecutive angles of a parallelogram are supplementary, so that's how we get that those angles are 140 and 140. The property that's applied here is that the diagonals of the rhombus bisect the angles. So this 40-degree angle, the big angle of the rhombus, is 40 degrees, so the little angles, therefore... Okay, that was weird. It cut off on me. Yeah, you got 20-degree angles, 70-degree angles. Therefore, these smaller angles are complements. We turn the page. We're going to do these 3 questions, and we're done with this part of it. See what you can figure out about these angle measures. I'm going to let you try using these properties. See what you can figure out. Pause the video. I'll come back in a second. All right, you should be resuming your video after you have your answers to 1. Here they are. Pause it again if that's all you've done. Here are the answers to 4 and 6. All right, be safe and get some rest, everybody, and stay warm. We'll continue this next time.